Okay, so today we are going to do factoring, trinomials, when a equals 1. Okay, when you have a trinomial, it is in the form of ax squared plus bx plus c. So the coefficient, or in other words, the number in front of the squared term or the quadratic term is a. The number that is in front, or the coefficient of the linear or the x term, is b, and then your number is c. So if I give you 3x squared minus 4x plus 7, you are going to need to recognize that a is 3, b is -4, and c equals 7. Okay, now we are not there yet, but you need to be able to recognize that. Okay, so if we are factoring trinomials when a equals 1, we start off with one that has p squared plus 14p plus 40. The reason I teach you this method is because it works when you have a trinomial, when a is 1, when a is not 1. It works on difference of perfect squares. It works on factoring by grouping. So I do really like this method. It is called the product sum method, or factor by grouping. So we are going to create a product sum table. Now eventually you might not have to use this table, but for right now we're going to use it as a tool to help us better understand what's going on. The product comes from a times c. So in this case, my a is 1, so it is 1 times 40, which gives me 40. My sum is b, and so in this case my b is 14. So I need to think of two numbers that multiply, because that's what product means, multiply to give me 40, but add together, because that's my sum, add together to give me 14. So just generally start making a list. 1 times 40, you could do 2 times 20. I am leaving just a little bit of space here because I do have a reason. 3, nope, 3 doesn't go in there. 4 times 10, 5, yep, 5 times 8, and 6, 7, we're right back to 8 again. Keep in mind, 1 times 40 gives me a positive 40, but also -1 times a -40 gives me a positive 40. So for each pair of factors you have another pair with either 2 negatives or 2 positives, or changing the negative to the other number. -2 times a -20, -4 times a -10, and we also have -5 times a -8. So right there's 1, 2, 3, 4, 5, 6, 7, 8 possible choices that I could be using. I need to figure out which of these pairs will add together to give me 14. Well, 1 plus 41 equals, 1 plus 40 equals 41. That's not it. If I do the opposites of the -1 and the -40, it's just going to give me the opposite number. So I really don't need to be trying those. 2 times 20, so 2 plus 20 gives me 22. So I know the other pair is going to give me a -22. That's not what I'm looking for. 4 plus 10 gives me 14. Ooh, positive 14, that's what I'm looking for. So I'm going to call the 4 and the 10 my two magic numbers, because those are the ones that I'm going to use. When a is 1, it creates a special case. So I'm going to a trinomial, I'm going to put this up here, a trinomial factors into two binomials. So I know that since I have a trinomial, I am going to end up with two binomials. When a is 1, you can create some shortcuts. What creates p squared? And that is a p and a p. Now I'm going to take my two magic numbers of 4 and 10. It is a positive 4 and a positive 10. That's it. I can check it by FOIL. So p times p gives me p squared. Outers, p times 10 gives me a positive 10p. Inners gives me a positive 4p. And last gives me a positive 40. Those are like terms. P squared plus 14p plus 40 is what I should have started off with. It works, it checks, so I know my answer is correct. Let's do one with a negative. Let's do x squared minus 9x plus 14. So a is still 1. I'm going to create my product sum table. Product comes from a times c. So 1 times 14 is going to give me 14. Sum is b. Make sure you're watching the signs. It is a negative 9. So I need two numbers that multiply to give me 14, but add together to give me a negative 9. Well, 2 and 7 right away I think of. 2 times 7 gives me 14, but 2 plus 7 gives me a positive 9. So I know that if I make them both negative, I still get the positive 14 when I multiply, and now when I add them, I do get a negative 9. So negative 2 and negative 7 are my two magic numbers. It's a trinomial. It's going to factor into two binomials. X squared is created from x times x. I'm going to use my two magic numbers of negative 2 and negative 7. And you're done. If you end up with magic numbers of negative 7 and negative 2, what that means is that your binomials are just going to be switched around. That is perfectly fine. 3 times 4 is the same thing as 4 times 3 because of the commutative property of multiplication. Here are some activities I'd like you to try. So activity 1. So give this a try and then come to class with this completed. Let's see. Let's try n squared plus 10n plus 16. In activity 2, let's try k squared minus 4k minus 60. So try those two. Keep in mind where we are going with this is that you are going to have to end up doing the greatest common factor first. Actually, I will throw one of those in right now. If you have 3r squared plus 21r plus 30, a is not 1, but if I take out a greatest common factor of 3, that leaves r squared plus 7r plus 10. Now I'm going to focus on this trinomial. So I'm going to cover that up so it doesn't confuse me. I don't need to use it. This is going to end up giving me two binomials of r plus 5 and r plus 2. But don't forget to bring down your greatest common factor. This would be your answer. So even though we're not quite there yet, you should be always looking for the greatest common factor first.